Okay, hello everybody. This is a normal, I'm calculating normal distribution practice using two free response. So get a couple things for one. So the first example is gonna be finding the area under normal curve and then move into a little sampling distribution, which is still an area under normal curve. So we have this trains carrying bauxite ore from a mine in Canada to an aluminum processing plant in northern New York State in hopper cars. Filling equipment is used to load the ore into the hopper cars. When functioning properly, the actual weights of ore loaded into each car by the filling equipment are approximately normally distributed, mean 70 tons and standard deviation 0.9 ton. The mean is greater than 70 tons, the loading mechanism is overfilling. Okay, so they give us a normal distribution, mean and standard deviation of that distribution. The filling equipment is functioning properly. What is the probability that the weight of the ore in a randomly selected car will be 70.7 tons or more? And it says show your work. Okay, so when you come to a problem like this, I always start first, draw my information. I know that the mean is 70, so I draw my curve. This is acting as my work right here, is showing this 70. Standard deviation is 0.9, and I would count 1, 2, 3 standard deviations above. I locate my value of interest on this curve, which is just under 1 standard deviation. And then now I'm going to start calculating this on the calculator. And normally you'd go to Statlet, where you enter the mean and standard deviation. This is not much different. So I go to second distribution. The function I want is normal CDF. I hit enter. Here, if I look on my curve, the lower bound, I always go from left to right, where my area starts is at 70.7. The upper area, well, that keeps going. So I'm just going to put in a really big number, 99999. Mean of 70, standard deviation of 0.9. I hit enter, and I get that my area is 0.2183. Let's go ahead and look at the rest of this question. This was kind of a part A. Part B says, suppose that the weight of ore in a randomly selected car is 70.7. Would this fact make you suspect that the loading mechanism is overfilling cars? So this is really building on this. And so I'm going to use this probability basically to make a decision. And this decision is really kind of like a hypothesis test, because I'm checking to see, and if I go back to the wording, it had said, if the mean is over 70, then I suspect overfilling. And if I have one car with 70.7, is that suspicious? And the answer is, this is a pretty big probability. So the answer is no. I would not suspect that the mean is greater than 70, since 0.218 is not that unlikely. So when you have a probability question, you're asked about, does it make you suspicious? Start thinking that, hey, the whole point of this is, are we have we passed that reasonable doubt of significance level? And no, this is not an unlikely result. So then we can continue on. The next part of the question continues, and it says, if the filling machine is functioning properly, what is the probability that a random sample of 10 cars will have a mean? So this looks very similar to part A, but what the real difference here is that I'm no longer just dealing with one. I have a random sample. And so that, okay, my mean is still 70, but my standard deviation gets smaller, and it gets smaller in a way that I can predict. I actually do the standard deviation divided by the square root of the sample size, which this is the sampling distribution. So it went from a single car to a sampling distribution problem. And now I can calculate this again. When I do 0.9 divided by square root 10, I get 0.2846. So I'll do second distribution, normal CDF. I'm leaving everything the same except changing that standard deviation to 0.2846. And when I enter that in, now I have a very unlikely result. This happens only 0.007 of the time. And guess what? Part D asks the same question again, is would this make us suspicious? The first one was not that unlikely, about over 20% of the time. This one, less than 1% of the time. So in this case, yes, I would suspect the machine of overfilling, since this is so unlikely. So a couple important things to kind of watch for that I would think might be similar on the test is that this problem It goes from sampling a single car to then sampling a sample. Watch for that change in distribution, that getting that smaller standard deviation. And then here are these sort of like hidden hypothesis tests that once I calculate a probability, this I can treat just like a p-value and say, you know, if it would make me suspicious. Okay, so now we're going to move on to another free response example. This time we're going to find values given an area. This is going to be an inverse norm calculation. So a city council is considering funding a proposal to create a new city park. The city council members will fund the proposal if they conclude that more than 60% of the city residents support the proposal. A survey of 2,000 randomly selected city residents will be conducted to investigate the level of support for the proposal. Let X equal the number of city residents in the sample who support the proposal, and assume that X is a binomial random variable. Determine the mean and standard deviation of the random variable. Okay, so and assuming that 60% of the residents support the random proposal. So first thing to note is that this has a little bit of binomial information in it, which to know that. So where we can go, I'll first get down some of the important information. Right, that I've got the number of city residents. I've got this n equals 2,000. That's my sample size, and then it tells me that this p is 0.6, and then because we're assuming that's true, and that assumption that 60% that is really like a null hypothesis. So we're already kind of being set up for some sort of hypothesis test situation. If you're asked for some formulas, the binomial formulas are right here. The mean, I just take my sample size and multiply by the probability. So it's like my expected count. I take whatever I count, the expected proportion, and I multiply. The standard deviation looks a lot like the standard deviation for a proportion, except the n is on the top instead of the bottom. So then let's get started. So for mean, I just do 2,000 times 0.6, easy enough, I get 1,200. For the standard deviation, I do square root 2,000 times 0.6 times 0.4, which is really just that 1 minus p. I get 21.9. Okay, on to the next part. So now, if I let's look to the next part of the problem. They have a normal distribution. N times p was obviously 1,200. That was greater than 10, and n times 1 minus p would be 800, right, to that complement. And so that's also greater than 10, so we can use a normal approximation to the binomial. And they now have this shaded curve with 0.997 in the middle. So it says we're assume that the 60% is the mean, and so that mean is going to be 1,200 in the middle of our curve, and we want to use a normal approximation in the mean and standard deviation to determine the values. So that 0.997 is an area. If I draw this in here, I know that right in the middle is this 1,200 that I'm expecting, and I want to go some in each direction to find some estimates. So if 0.997 is in the middle, that means I have 0.003 in the tails. I split that in two, and I get 0.0015, 0.0015 on each tail. So then to calculate this, here is where the normal calculation is going to come in. So some things to know. The first side, K, is pretty easy to find. Your calculator, when it does a normal curve, it does it to the left, finds the area to the left. So if I enter in my calculator, second distribution, actually, if I use second distribution and I go inverse norm, I get it like this, and the area I want to the left is 0.0015. My mean is 1,200, standard deviation is 21, and I paste that in there, and I get 1,335. So basically this is to the left, and I find that this number, if they're less than this, I will only have a 0.0015 chance of getting that if 1,200 is in fact the expected. To find the other one, I need to find all the area to the left. So I do 0.997 plus 0.00185, which is 0.998. Do the same calculation in my calculator. Second distribution, INV norm is 0.88. Sorry, not 0.88, 0.9985. Mean standard deviation, hit enter, and I get 1265. And so I'm really going like 65 people in each direction for these numbers. So I get my two values. The final question is basically then setting up again for a hypothesis test. It says the survey was conducted and 1293 of the 2,000 residents surveyed supported the proposal. Do your answers in part B and the survey results support the funding of the proposal? So again, what I'm looking for in this is that I'm looking for that this is a hypothesis test. I have a confidence interval, really, right? That's a confidence interval. It could be like 99.7% confidence interval because the area in between is 99.7%. So you could use either the language of the confidence interval or the hypothesis test. And this result does support the funding because this number, 1293, falls above that boundary value of the confidence interval. And so it does provide evidence that the mean expected is above 2,000. The sample result is very unlikely, right? Less than 0.005. That's the probability of that occurring. And it is much more likely that that more than 60% of the people support the proposal. So I have my full confidence interval. All right, hope this helped with calculator and a couple of free responses. All right, everybody have a great day and I will see you soon.